usual, we start this problem by deciding upon our coordinate axes and drawing a free body diagram. This time we're going to use a cylindrical coordinate system where we have the z-axis acting vertically upwards and the r-axis acting radially inwards. So let's ask ourselves what forces are actually acting on an occupant of the rotor. Well, first of all, there's the weight of the occupant acting vertically downwards, and then upwards we have the static frictional force due to the surface of the rotor. P is the centripetal force exerted by the wall on the occupant, causing him to move in a circle. Right, now let us look at our equations of motion. In the vertical direction, the resultant force is the friction force minus the weight, mg, and that must be equal to 0 because there is no acceleration in the vertical direction. And therefore, the frictional force is just equal to the weight. But we also know that the frictional force is equal to the coefficient of friction times the normal reaction force between the occupant and the rotor. Now, in actual fact, that force is the same force as P, and therefore the frictional force is equal to mu times P, and therefore P is equal to the friction force divided by the coefficient of friction, which is just equal to mg divided by mu subscript s.